Hello and welcome back to your channel Physics Safari. My name is Abhishek and today I'm going to discuss with you the kinematics. Before this I have discussed with you the basic mathematics for the physics and I'm sure you guys must have seen that. If not, I'm going to drop the link in the description box. You can go and check out over there. So when we deal with the kinematics, basically it is a branch of physics that deals with the motion without actually dealing the cause of the motion. सिर्फ मोशन की पैरामीटर से डील करता है, not the reason why the motion is there. All good? So first of all, let us understand what do you mean by the word motion. Motion से आप समझते क्या हो? What do you mean by the word motion? Now let me tell you one thing, that when a body's position is changing with respect to time, over the period of time, with respect to an observer, the body is said to be in motion. For example, let's suppose the earth, if you're standing, we are on the earth, and with respect to us, the earth is not moving. We find it at rest. But in reality, it is not at rest. It move kar raha hota, right? So, just to decide whether the body is in rest or in state of motion, we need an observer. Vina observer ke we cannot decide whether the body is at rest or the motion. All good? So, in simple language, a body is said to be in motion when position, or you can say the position vector also you can say, when the position or position vector of object changes, okay, over a period of time with respect to the observer, ऐसा हो रहा है, then the body is said to be at in motion, और ऐसा नहीं हो रहा है, then the body is said to be at rest. So let's say if I have an object over here and the observer is placed here, its position vector is, let's suppose, r, and if over the period of time, if the position vector is changing, the body will be said to be said to be in motion, my bad. So if r could be represented as a function of time, then the body is said to be, this implies the body is in motion. And when r is a constant, it is not changing, then the body is said to be at rest. What exactly do we mean by the word function of time? Function of time means over the time its position vector would change. As simple as that. Clear बात है ना जी? Okay. अब थोड़ा और समझते हैं कि how many type of motion and how many types of rest we have. So broadly, if I look at the motion, later on we'll see we have uniform motion and the another one is a non-uniform motion. Non-uniform motion. And when I talk about the rest, we have instantaneous rest, and we have rest, or you can say the permanent rest, as simple as that. Instantaneous rest means when the body comes to the rest for a very small amount of time. At that particular time, if the body is at rest, that is called instantaneous rest. And when the body is at rest for a slightly longer period of time, then that is called as rest, or you can say permanent rest. Instantaneous rest ka example if you want to see, well, when I say that a body, when you throw it upward, ऊपर फेंकते हो आप, so before at the top position or the maximum position, before it starts coming down, it comes to a momentary rest, or you can say instantaneous rest. इस point पे before it starts coming down, at this point the body is at instantaneous or momentary rest. इतना बात clear है? Now when it comes to uniform motion, simple as that, if its position changes at a uniform rate, means एक घंटे में 1 किलोमीटर चल रहा है, then in next 1 hour again 1 kilometer ही चलेगा, or it could be meter or whatever. But over a given time period, the difference in the position vector would be same displacement या distance वो cover up करेगा for a given time period. That is called the uniform motion. Non-uniform, just opposite, for a given time period, non-equal displacement or distance is covered, then it is said to be in the non-uniform motion. चलो अच्छी बात है. इतना क्लियर है जी? Now one more thing that we need to understand. Okay, ठीक है, मान लिया the body is in motion, its position vector is changing. Now at what rate the position vector is changing is given by the velocity. All clear? Now, so we have one more term that says that defines the rate of change of the position vector. Rate of change of the position vector. And that is called velocity. Now, there is going to be a case when we have the non-uniform motion, even the velocity would change. तभी तो same time में it can cover the non-equal distance. It means velocity is changing. So there must be something which tells you about the rate of change of velocity, and my dear, that is called as acceleration. उसको बोलते हैं जी acceleration. Now, we can have two cases of, one is of constant acceleration and other gonna be of different, or you can say non-constant or changing acceleration. Okay, non-uniform acceleration we can say. So in that case, that would be given as how much? That would depends upon the force. So force will tell you about the acceleration, and that we know from this very fundamental equation, F is equals to ma, and we're going to deal about this detail in dynamics of physics. So the bottom line is force decides the acceleration, acceleration decides the rate of change of velocity, and the velocity will decide at what rate the displacement vector is changing. इतनी बातें क्लियर होगी सबको? बहुत अच्छा. अब थोड़ा आगे बढ़ते हैं और देखते हैं कि भैया पोजीशन वेक्टर जो चेंज हो रहा है, जो वेलोसिटी हो रहा है, इसको हम लोग कैसे डील करते हैं. ऑल गुड? बट बिफोर दैट वी नीड टू अंडरस्टैंड कि अ मोशन ऑफ अ बॉडी कैन बी डिस्क्राइब्ड इन इट्स पैरामीटर, और हम लोग को आगे पढ़ना है जी पैरामीटर्स ऑफ द मोशन. So basically the parameters are those terms. I'm sure you guys have noted down, right? If not, you can just pause the video, go slightly backward, and you can pause you can note down. ध्यान से सुनना, काफी इंपॉर्टेंट है चैप्टर. The reason being kinematics is the fundamental of physics, basic है, इसका backbone है. Over the period of time, we're going to build a huge better concepts on this, और भी इसमें सीखेंगे हम लोग. तो important है इसको अच्छे से समझना, एक एक लाइन को बारीकी से समझना. Because in this video, I'm not going to be talking unnecessary things. I would stick to the point. No unnecessary stuff would be discussed over here. तो जो भी बातें बता रहा हूँ उसको अच्छे से आप लोग नोट कर लेना चाहिए. Okay. Now let us discuss about the parameters of the motion. हम लोग थोड़ा सा बात करते हैं parameters पे. What are the parameters that decides the kinematics of the motion, that decides the value, numerical elements of the motion? So parameters of, you can say, kinematics. Parameters of kinematics. तो बेसिकली इसमें पहला चीज जो अपन को पढ़ना है, that is called displacement. That is called displacement. Now, it's a counterpart in this scalar quantity is the distance. अपन इसको भी हम लोग पढ़ेंगे. We'll also discuss the distance. Number 2 is the velocity. We will talk about the velocity, and the scalar counterpart of that is speed. Going further, we will deal with the acceleration. We'll deal with the acceleration. ये सारे बातें हम लोग वन बाय वन थोड़ा डिटेल में समझेंगे. ऑल गुड? चलिए, अच्छी बात है. नाउ इफ आई टॉक अबाउट द डिस्प्लेसमेंट एंड डिस्टेंस, थोड़ा उसको पहले समझ लेते हैं, फिर आगे बढ़ेंगे टुवर्ड्स द वेलोसिटी एंड द स्पीड. नाउ डिस्प्लेसमेंट होता क्या है? टू अंडरस्टैंड दैट, लेट मी टेक अ सिचुएशन. भैया अ बॉडी ए travel from, let's suppose, A to B, ऐसा कुछ गया to B. Well, this is the actual path taken. This is the actual path. ये भैया अपना actual path उसका real path है. ऐसे body is moving from point A to point B. किसी ने बोला कि ठीक है चलो, let's suppose I was moving along this path in my car. मैं ऐसे घूम फिर के आराम से गया. It consumed a lot of fuel, और आपको पता ही है the fuel is costly. But किसी महारथी ने बोला, some hi-fi smart fellow came and said, sir, why are you moving in this path? Why don't you just go in straight path? ऐसे चले जाओ आप. बोला बहुत अच्छे भाई, मान लो कि ये तो खाई वाई है, गड्ढा वड्ढा है, इसने तो मेरे को खुदाई देना था. बट उसने बोला. So it makes a slight sense. It makes a little bit of sense over there. ठीक है. So this would be a direct movement from point A to point B. And इसको नाम दिया गया जी डिस्प्लेसमेंट. दिस इज कॉल्ड एज डिस्प्लेसमेंट. तो भैया डिस्प्लेसमेंट है क्या? Displacement is the shortest distance between the 2 points. All good? Shortest distance. इससे छोटा distance A और B के बीच में हो नहीं सकता है. तो एक बात तो समझ में आ गया कि the actual path which is longer than this path, though despite being real, it becomes complicated to study. ठीक है, यहाँ पे तो it's looking very much similar, simple. But let's suppose if I'm moving in very zigzag path, unnecessary उल्टा पुल्टा घूम लिया, then study of that actual path would become complicated. But मेरे को दिख रहा है कि this path is quite an easy path as far as its mathematics is concerned. Now, despite being imaginary path, a imaginary vector, इसको बोल सकते हो, this is a imaginary vector. Imaginary vector, right? So, despite being an imaginary vector, still our lot of studies, most of the mathematical studies goes along with the displacement. तो पहले displacement को थोड़ा define करते हैं जी. So, displacement is defined as, okay, an imaginary vector joining initial and the final position. Initial and final position. As simple as that. और इसको सरल भाषा में बोल सकते हैं shortest distance between 2 points. Between the 2 points. चलो ठीक है, समझ लिया. डिस्टेंस को हम लोग थोड़ा सा इसको समझते हैं. This is the actual path or actual distance or you can say actual length between 2 points. And it depends upon the path taken. जिस path में जा रहे हो उस पर डिपेंड करता है. But this is a complicated one. एक स्पिनर ने बॉल को थ्रो करा and the ball, one point of the ball would be taking so many various path, and study of that becomes complex. So that is the reason why we have with the displacement, and this helps you to understand the path, mathematical aspect of the path in an easy way. So that is why displacement is so damn important. तो एक बात तो यहाँ से क्लियर होगी मेरे को, that displacement का magnitude is always going to be less than or equals to the distance. Distance से कभी बड़ा नहीं होगा जी. And in which case it is going to be equal? When the actual path भी along ऐसे ही हो. Suppose there is a straight road, in that case the distance and displacement are both going to be equal, and that is the only time when the displacement and distance is going to be equal. Otherwise, distance is always going to be bigger than that, greater than that. All good? इतना बात तो अपने को क्लियर हो गया जी. अच्छी बात है. थोड़ा और समझते हैं इसके बारे में, अच्छा, इसको हम लोग इरेज कर लेते हैं. We gonna erase this. So we have understood क्या जी? Distance and displacement. इतना बात आप लोग को समझ में आ गया है. अब सीखते हैं. Now let us learn how to find the displacement vector between the two positions, 2 points. थोड़ा उसके इस बारे में सीख लेते हैं. Let us learn that way. So you can say, let's suppose if I have a reference, observer is here. Now let's suppose initial position is Ri, and the body moved to another point with the position vector of Rf. Now, if I take a vector joining this initial point and the final point, that would be called your displacement vector. So this S is representation of displacement vector. इतनी बात अपन को समझ में आ गई है. Now, using the triangle rules of vector addition, I'm sure you must have read the triangle rule. नहीं तो एक बार बता देता हूँ. If two sides of a triangle are taken in the same direction, then the third side in the opposite direction will be the sum of these two vectors. Means, if this is your vector A, this is your vector B, and if it is C, then C could be written as, vector C could be written as A plus vector B. ऐसा होता है जी आपका triangle rule. Using that, if I look at this entire stuff, I could say that your vector, initial vector Ri plus this vector S vector should be equals to final position vector. It means the displacement vector could be calculated as or could be obtained as final position vector माइनस द इनिशियल पोजीशन वेक्टर. इंपॉर्टेंट है, देख लो इसको. So that's how we can easily find the displacement vector. Okay, you want an example? Example ले ले एक. चलो ठीक है जी. So let us say I have a point P with coordinates 1, 2, 3 and one more point Q. Q ले लेते हैं जी. This is your initial position vector Ri. This is your final position vector Rf. Observer is here. इसका भी कुछ मान लो जी. 4, maybe 2 और कुछ भी ले लो, 3 ले लो, क्या जा रहा है, और मे बी यू कैन से 6 ले लो, या फिर डिक्रीज कर लेते हैं, 1 कर लेते हैं जी, है ना. सो इफ आई वांट टू फाइंड द पोजीशन वेक्टर, डिस्प्लेसमेंट वेक्टर, माय बैड, इफ आई वांट टू फाइंड द डिस्प्लेसमेंट वेक्टर दैट इज ओवर हियर फ्रॉम दिस पॉइंट टू दिस पॉइंट. नाउ आई एम श्योर यू नो हाउ टू राइट दिस इन टर्म्स ऑफ these are the coordinates. If you want to write in terms of vectors, how would you write that? एक एग्जांपल बताया था. The point P 1, 2 and 3 could be written as I cap plus 2, J cap plus 3, K cap, है ना जी. This is your, let's suppose, OP vector. I can write OP vector could be given as this. Likewise, OQ vector also we can write. So the OQ vector could also be written as what? Your 4 I cap plus 2 J cap plus K cap. What do we need? We need this displacement vector. This displacement vector we need. So using this, you can say what? R final minus R initial. That's what we can find. So your displacement vector over here should be how much? 4i minus I, 3i cap, 2j minus 2j. Simple. 2j, you know, though it is not actually correct. If 2 is here, then 2 cannot be here. But ठीक है, चलो मान लेते हैं क्या जा रहा है उसमें. And k minus 3, 1 minus 3, that's going to be minus 2 k cap. Geometrically, it's looking slightly incorrect, but ठीक है. So this is your displacement vector. So ऐसे we can find the displacement vector if the coordinates is given, or else if it is given in this format, तो directly we can just use this up, है ना. कोई दिक्कत इसमें किसी को नहीं ना. बढ़िया. अब थोड़ा देखते हैं displacement vector को और distance को. Let us deal in little slight detail. थोड़ा और समझते हैं उसको. So ये हो गया जी आपका. ये भाई साहब चला गया. Now let us study the displacement vector. थोड़ा और समझते हैं उसके बारे में. Okay, let's say I have initial vector, initial position vector over here. This is the initial position vector. This wire gets tangled. Okay, anyways, so let's say here we have. Let's suppose this is the position vector of the object. यहाँ पे. This is the O. कुछ भी मान लो A ले लेते हैं ना. At any time t, at time t. Now we have a very small displacement, okay? Now we have a very small displacement in time delta t. So small displacement, you know? Or you can also say that's an instantaneous displacement, G. You can say it is an instantaneous displacement. Chota sa, small. So if it is a small, then definitely the time period should also be small. So in small time delta t dt, you can say the body has come here. So आपका जो time हुआ from t, it reaches to t plus dt. इतने time पे the position of the body changed from r to, let's suppose, small displacement vector. So r plus, let's say, dr. छोटा सा change, small change, slight change in small time, because time is also very small. छोटा सा time में छोटा सा displacement है ना. दिल है छोटा सा, छोटी सी आशा. Okay, now again let us use the triangle rule of vector addition. So can I just say r vector plus, let's say I can write ds vector, that should be how much? r plus dr vector. भाई देखो r तो गया जी. What do we have? We can see the displacement vector could also be written as, you know, your change in this position vector. बड़ा important बात है जी. Small change in displacement vector is equals to small change in position vector. It is very important, and it is valid only for small changes, not for the big change, you know. So for the small change in displacement vector is equals to small change in the position vector. I'm going to use it. But थोड़ा सा पीछे जाएंगे हम लोग. If we go slight backward, we had seen that velocity vector was written as what? dr upon dt. If you remember, in the initial part, I have written this. Now since dr is equals to ds, can I say the velocity vector could be also written as ds vector upon dt vector. dt of course time is not a vector, no. So इसको क्या लिख सकते हैं हम लोग जी? Velocity is all about rate of change of displacement, rate of change of displacement और displacement vector लिख दो जी. I know displacement is a vector, but लिखने में क्या ही जा रहा है ना? तो सिंपल सी बात, इतना बात अपने को समझ में आ गया जी. So velocity is all about rate of change of the displacement vector. एक बात तो और अपने को क्लियर हो गया कि for a small time interval, ds and dr are same. That is, change in displacement is equals to change in the position vector. Okay. तो फ्रॉम हियर अपने को थोड़ा सा और सीखने को मिल सकता है कुछ है ना. आई कैन एक्चुअली रिलेट डिस्टेंस एंड डिस्प्लेसमेंट समहाउ. कुछ वहां पे हम लोग कर सकते हैं. चलो कोशिश करते हैं करने का. नाउ लेट्स से द बॉडी मूव फ्रॉम हियर टू हियर. ऐसे कुछ आया बॉडी फ्रॉम पॉइंट ए टू पॉइंट बी. एज वही सेम एक स्मार्ट फेलो ने बोला सर इसको ज्वाइन कर दो जी. ठीक है, मैंने बोला ओके. अब ध्यान देना, the gap between distance and the displacement कुछ तो है. there is a gap. ये ज्यादा है and this is small. Let's suppose if I, and for a certain time t, कुछ time t के लिए the displacement vector and this is the distance. If I decrease the time period और उसको छोटा कर देते हैं, maybe for this time period or for the small time period, say this, the difference, mark my word, the difference in the actual distance and the displacement now is less. अब थोड़ा वो difference है वो कम जाएगा, right? And if I decrease the time interval और छोटा कर the time interval, then the difference in the distance and the displacement vector is going to reduce further. So what exactly I've seen, if I reduce the time period, the differences between the actual path and the real path becomes lesser. Likewise, if I reduce this small time interval to a very small value dt, then I can say for a very small time interval, देखते हैं what happens, then we're gonna write it up over here. Let me take this place. For a small time, छोटे से time के लिए, देखो, it is gonna be your instantaneous displacement, my dear. This is the instantaneous displacement. इसको और छोटा कर दे जी, इतना छोटा टाइम कर दे, बहुत छोटा, almost tending to zero, right? That means it is a dt. छोटा सा for a small time interval. देखो, this line becomes almost straight. If you can see that, this line becomes almost straight. Now what can we conclude? Say this. This is valid for small time, right? It means for a small time period, the displacement vector and the position vector, which is the position vector, change in position vector becomes same. So can I say that for a very small time interval, the instantaneous displacement becomes equals to the distance, becomes equal to the distance, है ना जी, for a small time interval. अच्छा जी, तो एक बात तो अपने को यहाँ पे और भी समझ में आ रही है कि अगर displacement is going to be equals to a distance, and if I let's suppose if I consider more small displacement, you know, instantaneous displacement, let's suppose this is your ds1, ds2, ds3, ds4, and so on. If I add all of these displacement vector, you know, if I add all of these displacement vector, I take the vector sum of all these displacement vector, that would give you the net displacement. और हम लोग उसको polygon rule से solve करते हैं. We cannot do that by the polygon rules of vector addition. So exactly what I mean to say, if let's say this is the distance and this is your displacement vector, and these are the small displacement over at different positions, you can say, for a small time interval. So vector sum of instantaneous displacement vector instantaneous displacement vector gives the net displacement, and it would be along the vector AB, and it will be along vector AB, Acha ji. And this has to be done by the polygon rule of vector addition. So, if I say that, if I take the sum of all these displacement vector, so let's suppose this is I, where I is equals to 1 to n, then that is going to give you the net displacement. इस बात को note कर लो आप लोग. And if I take the algebraic sum, normal sum of these magnitude of these displacement vector G, then that would give you what? Let's suppose I is equals to 1 to n, that is going to give you distance. That is going to give you the distance. इस बात को ध्यान से समझ लो, लिख लो. Vector sum of the displacement, small instantaneous displacement vector, going to give you the net displacement, and that is going to be along AB, and this sum of the magnitude of the instantaneous displacement vector would give you the net distance traveled. अगर इतना बात clear हो गया है, if it is all clear, let me just erase this part. अगर इतना बात clear हो गया तो मैं कुछ mathematically यहाँ पे we can form a relation. Remember initially what we had said, the magnitude of the displacement, was either equals to or less than the distance. इसको mathematically we can write as what? Sigma of ds, let's suppose I, where I is equals to 1 to n, is going to be lesser than or equals to displacement vectors magnitude and summation of that from, let's suppose I is equals to n I to n. That is what we have. इसका ले लो magnitude, है ना जी? So mathematically this is the language format and this is how we have to write the mathematical part of it. इतना बात clear है जी सबको? हाँ जी? You can just make a note of this one. You can make a note of this one. All good? You can pause the video, लिख लो. If you want to add up some comment in your language, you can please go ahead. And note it down. अब थोड़ा हम लोग पढ़ेंगे velocity vectors के बारे में, acceleration vector के बारे में, and displacement vector के बारे में. All good? So let's do one thing. Let's first erase this, and we're going to talk about that. And we're going to do some numericals. In that. So let's keep that for the next part. In the next part, we're going to talk about the velocity vectors, displacement vector, average velocity, instantaneous velocity, average acceleration. All this stuff we'll discuss in the next video, and we are going to do a few basic numericals, and I'm going to increase the level slowly, gradually. So make sure you watch all the part of the videos. That will just give you a deep insight of this kinematics. All good then? Then thanks for watching. Be in touch. And if you have any doubts or you want to be in connect with me, you have the comment box. Also, I'm going to provide my email ID in the descriptive links. All good? All right, guys. See you guys in the next video. Take care. Goodbye.